Hello everyone, we're going to go over with lesson 18.3, corresponding parts of congruent figures are congruent today. Our essential question, what can you conclude about two figures that are congruent? You will investigate some conclusions you can make when you know that two figures are congruent. Let's fold a sheet of paper in half. Use a straight edge to draw a triangle on the folded sheet. Then cut out the triangle, cutting through both layers of paper to produce two congruent triangles, like this one, and label them as triangle ABC and triangle DEF as shown. Place triangles next to each other on a desktop. Since triangles are congruent, there must be a sequence of rigid motions that maps triangle ABC to triangle DEF. Describe the sequence of rigid motions. Let's look at. What do you guys think? Yes. A translation, right? A translation maps triangle ABC to triangle DEF. The same sequence of rigid motions that maps triangle ABC to triangle DEF maps parts of triangle ABC to parts of triangle DEF. Complete the following. So let's look at segment AB maps to segment DE because segment AB corresponds to segment DE. And segment BC corresponds to segment EF. Segment AC corresponds to segment DF. Or in other words, segment AC maps to segment DF. Same thing with angles. Angle A, I'm going to change them to angles. Angle A maps to angle D, angle B maps to angle E, and angle C maps to angle F. Why does step C tell you about the corresponding parts of two triangles? Why? The corresponding parts are congruent because there is a sequence of rigid motions that maps each side or angle of triangle ABC to the corresponding side or angle of triangle DEF. Then we can make another conclusion here. Angles and segments are congruent and measurements are equal. Okay, Let's move on to the next page. If you know that triangle ABC is congruent to triangle DEF, what 6 congruent statements about segments and angles can you write? Why? If triangle ABC is congruent to triangle DEF, then you know each part will correspond to each other here. So order matters. We would like to start with line segment AB first. So segment AB is congruent to, using the same order, is here would be segment DE. And segment BC is congruent to segment EF. And segment AC is congruent to segment DF. The same idea with angles. Angle A is congruent to angle D. Angle B is congruent to angle E. Angle C is congruent to angle F. The rigid motions that map triangle ABC to triangle DEF also map the sides and angles of triangle ABC to the corresponding sides and angles of triangle DEF, which establishes congruence. Do your findings in this Explore apply the figures other than triangles? For instance, if you know that the quadrilaterals J, K, L, M and P, Q, R, S are congruent, can you make any conclusions about corresponding parts? Why or why not? The answer is yes, right? Since quadrilateral, let's shortcut it right here, J, K, L, M is congruent to quadrilateral P, Q, R, S, there is a sequence of rigid motions that maps quadrilateral JKLM to quadrilateral PQRS. So that this same sequence of rigid motions maps sides and angles of quadrilateral JKLM to the corresponding sides and angles of quadrilateral PQRS. So the last part of this section is the corresponding parts of congruent figures are congruent true statement. So the following true statement summarizes what you discovered in the Explore. Corresponding parts of congruent figures are congruent. We can also use kind of initials to make it a little bit shorter when we wanted to write it in the future. So corresponding parts of congruent figures are congruent. Okay, now let's move on to the next page, which is page 911. And we're going to look at question number 3. The triangles shown in the figure are congruent. Can you conclude that segment JK is congruent to segment QR? Explain. Let's look at here. The answer is no. The segments appear to be congruent, but correspondence, in other terms, congruent statement but correspondence, which is the congruent statement, is not there. So we cannot assume segment JK and segment QR are corresponding parts.